Hello there students and welcome to Year 10 Science. This is Motion and Energy and video number 3 on acceleration. So in this particular video what we're going to do is just to introduce the idea of acceleration in both a qualitative and a quantitative way. For the qualitative description of acceleration, we're just looking at the rate of change of speed. So any object that is getting faster or slower is accelerating. And it's important to be aware of the fact that acceleration can have a negative component. We may refer to it as decelerating, but that negative component actually means that the speed of the object or body is decreasing rather than increasing. But as long as the object is getting faster or slower, there's a change in speed, then we can talk about acceleration. Now specifically and mathematically, so quantitatively, acceleration is the rate of change in speed, and we can calculate that mathematically by looking at the change in speed or velocity. Sometimes the final velocity minus the initial velocity is used, and dividing that by the time. So here is another mathematical relationship that says exactly the same thing. Change in velocity over change of time, that gives you acceleration. And as we talked about, if the value of the initial velocity is actually larger, then acceleration can be a negative value. That is, it's slowing the object down. We've talked about SI units, and the SI units for acceleration are meters per second per second. So if the change in if it's the rate of change in speed or velocity, we know that speed or velocity is measured in meters per second. So meters per second gives us this one. Now this is quite a messy unit, so we kind of put it together as meters per second squared, or sometimes meters seconds to the minus 2. Okay, don't get too worried about indices at this point in time. If you're not comfortable using these, this is perfectly fine. Because acceleration is often related to a change in velocity, acceleration is also a vector quantity. And as we should now know, that vector quantities are distinguished from scalar quantities by the fact that they have not only magnitude, but also a direction. And acceleration likewise has a direction. So we can talk about, or we can draw arrows to indicate the direction of the acceleration, or talk about the fact it's accelerating north or east or up or down. Negative acceleration, as I mentioned before, is referred to as deceleration, and it causes the speed or velocity to decrease. Now, one of the most interesting applications of acceleration is acceleration due to gravity. When we launch any projectile, when we throw a ball, kick a ball, anything that moves through the atmosphere is subject to the Earth's gravitational field, and therefore that object will accelerate due to gravity. Now this has actually been measured, and it's one of the things that we're doing. In fact, just last week we started to use the ticker timers to look at what happens to the motion of an object when it is allowed to fall under the influence of gravity. That gave us some results, and what we'll be doing is having a look at processing those results probably by the time you have watched this video. So we can actually experimentally calculate a value of acceleration due to gravity, and of course that's not the only way of doing that, but that gives us a value for what that acceleration on any falling object would be. Usually we use the symbol A to represent acceleration, but in the special case when that acceleration is due to gravity, we use the symbol G. So you'll often see the symbol G used to just represent acceleration due to gravity. And we'll be looking at a number of sporting applications where gravity is the most important force that's acting, causing that acceleration. So let's just look at a quick example before we go. We want to calculate the acceleration of an object that begins at rest and then accelerates to 10 meters per second in 25 seconds. This is an important word. Rest means that the initial velocity is equal to 0 meters per second. I should also point out often the symbol U is used for initial velocity. Either way, meters per second. Acceleration is equal to the change in velocity divided by the change in time. So therefore, if our final velocity is 10 meters per second and our initial was 0, and we have that acceleration happening over 25 seconds, then we have 10 over 25, which is 2/5 or 0.4 meters per second squared. Thanks for watching.